Hey, how you doing? This is OXDF, and we're looking at the Advent of Code 2015, day 24. It's Christmas Eve in September. The challenge is called "It Hangs in the Balance," and yeah, we're doing the Advent of Code in Rust to learn Rust. So let's check out the challenge. Basically, after the story, we're going to get a list of weights of every package that Santa needs to fit on the sleigh. The packages need to be split into three groups with exactly the same weight, and every package has to fit. And then the first group goes into the passenger compartment. So the first group needs to have as few packages as possible. So it has to be the same weight, but it has to be fewer packages. Um, and then if there's more than one way to arrange the packages, so that if the fewest number of packages in the passenger compartment is 4, and there's 3 different ways to arrange it with that, I want the smallest quantum entanglement, which is really just the product of those weights. So the summary is I need to take a long list of numbers, divide them into the equal groups so that their sums are equal, and then I need to find the smallest possible way to get one of those groups as small as possible, and then find the smallest product amongst those combinations. So actually, after day 23, this one's not so bad. Let's go ahead and jump over to VS Code. I'm going to start off with my GenDay script here for day 24. Details in video 0 or the intro video, but short version is it gives me the input.txt here, as well as a nice stub to start working on for my main. Let's go ahead, and one trick I've been liking is to split this to the left and shrink that. So we'll keep our input.txt over here on the side. We can see it. There's 29 lines, and from there. Okay. So this challenge was really hard for me to wrap my head around until I finally realized that if I know the total weight of all the packages, then I know the weight of each of the 3 groups. And with that, I can basically just start looking for, are there any combinations of size 1 that equal that number? No. Are there any combinations of two packages that find that number? No. Okay, what about 3? Until I get something. And then once I have something, now I've got all the combinations of that size. I just find the one that has the smallest quote unquote quantum entanglement. So with that in mind, we'll go ahead and give it a try. I'm gonna actually mess again with my thing here. I'm just gonna call this numbers, and I don't need to trim. Instead, I'm going to go ahead and do lines, so I get all the lines here, and then I'm going to map that. I'm going to take all these lines here, and I'm going to take, so some line here will be, line 5, 11. That's a string, and I'm going to just do x.parse dot unwrap like that. And I'm going to pass that into .collect, and we'll tell it it's a vec of u size like that. And I think actually I need another set of angle brackets like that. And that all looks awesome. This right here makes it so I don't need to tell it how to parse, because it can tell it needs to get to a u size. And so now we've got our numbers. We could even come down here and save that and cargo run release, and we got an error. Oh, we can't. Vectors cannot pretty print, or cannot standard print, but they can debug print. There we go. We've now read our numbers into numbers. Okay, so first let's get the let total weight, I guess we'll call it, equals numbers dot iter dot sum. Let's see if that will work. And consider giving an explicit type. Okay, u size. And now we can find out, what is the total weight. Again, I just like to see how it's going as we're going. Total weight is 1560. So presumably that is divisible by 3. We could check. It is 520. Cool. So now what we're going to do is we're going to find some combinations. So first thing we need to do is we'll say let mut, and we'll say like let's call it I for now, equals 1. It's gonna be like the number of packages in our combinations. We're gonna say let mut. I guess we'll just loop here actually. Loop, and so we can say let x equals numbers. Yep. All right. Dot iter. So we need an iterator. Dot combinations And now we're going to need the Itertools package. So we have use Itertools, like that. And that is going to require me to go back to my cargo.lock toml file and import Itertools. We'll be lazy and not get a version number. Close that, shrink that, save that. Did I not save it right? Did I put it in the lock? I don't know. Why? That's interesting. Did I close it without saving it? Did I do it in the wrong folder? Okay. Itertools equals star. That. Now this seems happy. Save. Combination takes a number. We'll do I. So what this is going to do right now in our unending loop, let's see. We can say I plus equals 1. We need to get our I. We still have a never-ending loop, but we'll get to that. So we're going to create a combinations of size iter. And what we really want to do is, so the next thing we're going to do is we're going to filter this. And we want to say we're going to have these vectors coming in. So each one of these is going to be a vector. Each combination is a combination of different numbers, right? And so we want to take that vector and we want to do v.iter.sum. And this time we are going to go ahead and tell it usize. That equals total weight divided by 3. And what don't we like about sum? Maybe nothing. Let's run. Oh, we are in an endless loop. And it knows that. Is that why it yelled at me? Okay, so we need a sum of that is not here. I did some Googling here, and I can't totally explain. So the thing we need to do here is we need to put a dot copied here. I believe this is going to solve this problem. Yep. And what this does here is it says, but the dot copy says, as you're iterating, give copies of the things. And that way we don't have to worry about ownership and the sum, the pointers and things like that. It works out. I found it on Stack Overflow. We're just going to have to go with it for now. So we now filter out so that we have that thing is equal to that. Now what's cool is this right here, we can say, so what we can do is we can come down here, we can say, if x dot count is greater than 0, break. Now, basically, as soon as we find something where something makes it through the filter, we're going to break. So we can run this, and we can verify we do exit. Now, let's say we want to print out x. Well, the problem we're going to have here is x doesn't exist in this scope. So what we actually need to do is come up here and say, let me shrink this. Let's call it something more interesting. Comms, we'll just say let comms, and that defines the scope, and we don't even have to make it mutable, and we can still change it once, even though we haven't set it yet. Now we can say comms equals, and save that, and we can say comms there, save that, and now when we come down here, we can say comms. And the bug output for comms is actually kind of ugly. Oops, and we're not there yet. Let's see. Comms.count is borrowed after move. I guess we can probably clone this. That works. Oh, cannot assign to a mutable variable. Oh, I guess we do need to make it mutable because we are going to assign more than once because we do the loop several times. Okay, makes sense. All right, so we got this. The output, the debug output for this is pretty awful. So let's do comms.collect that, and what if we can get it? Is that gonna, do we need to define? Yeah, so vec that. And now we can see it as a array. And so here we have a whole bunch of 1, 2, 3, 4, 5, 6 long combinations that all add up to 200, whatever that number was, 520, I think. So we've gotten all of the, so apparently there's no combinations of size 1, 2, 3, 4, 5 that add up to 520. But as soon as we get to 6, we get a bunch. In fact, let's see, we can see that blend. So can we get that? So there are 230 of them. So there's a lot. So now we need to find the one with the longest quantum entanglement. So this part's pretty cool. Let's see. So what we're going to do is we're going to map this. We'll say map. And so for each part of each item in the array, we want to take that vector. So we still have an array of vector, or a vector of vectors, right? So we're going to take this vector, which is a vector of u sizes, and we're going to say, let's just we can say v dot iter dot fold. And now this is the fastest way I know to multiply anything. So fold starts initialize an accumulator at 1. Then we have q comma x. So where q is that accumulator from the last round and x is the next new one. And we say we just want to return q times x. Like that. And so now we've got this map where we've turned everything into the product of itself. And really what we want to do, we want to be really clever now, we can say min and get the lowest one of those numbers. And what's cool now is min's actually going to return not a number, but a option of a number. And we talked about these enums in the last video in day 23. And basically, we're going to have an option there. And what makes that really nice is now we can say, this is no longer comms. Let's change this. Let's see. Rename symbol. We'll call this min quantum, I guess. And now we don't need to clone this. We can just say if the lowest quantum is not equal to none, because it's an option, so it could return none. If the array is empty and you go to get the min, it just returns none, then you break. And what's cool about that is now I can just go here and say min quantum. And as soon as I've broken, I've already got a number. And we'll save this and we will run that. And we have our sum on here. Let's do dot unwrap. Let's do dot unwrap. We'll save that. And we'll run. We get our number 184677, which looks pretty close to that right there. Ends in 891. Ends in 891. So we got it. That's simple actually. Let's go. We don't need this input anymore. Let's check out part 2. So the sleigh isn't balancing. Oh, we forgot a package. We actually have to split into 4 groups instead of 3. And now find the same challenge basically. So what we'll do here is we will grab this whole bit right here. And we will come up here and we will say fn best pack. And that's going to take v, which is a vec of u size. And it's going to take num space, which is a u size. And it's going to return a u size. And we're going to paste this in. So let's see. We are going to get a total weight, which is the size of, we'll change v to numbers. Okay. And why don't we want to break there? Oh, we don't do anything. Oh, we better return something. So when we get down here, we're going to return min quantum. Let's return a u size. Oh, we got to return min quantum dot unwrap. And now we are returning our u size. The only other thing we want to do is change here total weight over num spaces. And we have just turned this into a thing. So let's come down here and we can say best pack numbers and num spaces will be 3. So we're just redoing part 1 right now. We haven't actually made any new progress. We just want to make sure we see the same number here. We do. But now we can verify this with part 2. And we'll say best pack of 4. Numbers, let's go ahead and clone that so we don't lose the ownership stuff. And we run this and we get 83, 930, 59, 83, 930, 59. So day 24 in the books. My favorite part of this was this realization that I can do this whole chain, knowing that sometimes I'm going to get nothing back out of this min, and just use, as soon as I get none, I'm good to break out of here, unwrap it, and bang, we're good. So hope you enjoyed this, and thanks for sticking around to the end, and I'll talk to you next time.